Okay, so chapter 3, section 2. The good news is actually this is going to be a lot like chapter 3, section 1, with the exception of that today everything that we're going to talk about revolves around parallel lines. Certain geometry magic happens when we have parallel lines. There's a lot of nice things that happen for us to make our lives easier. That is not so easy when the lines aren't parallel. They become a little bit harder. So we're going to look at what happens when two lines are parallel. And remember, a transversal is just a line that cuts across two other lines. So what I'm imagining in my head when I hear this, I see two parallel lines. By the way, these arrows here are the symbol for parallel. They look like this. They're just two arrows. They don't mean congruent at all. That's not what they mean. That means that these two are parallel. They run like train tracks. They're equidistant apart. And a transversal just means that another line is coming across it. So right there we have two parallel lines and a transversal coming across it. That's basically what we're talking about today. Bless you. So here are some things that are true. So these are some postulates that we are going to work on. Now the names of the postulates are actually in the parentheses. So while you're writing, I'm going to draw out a little sketch here. I'm going to draw those same two parallel lines that I drew before with the arrows to indicate that these are parallel. I'm also going to add a transversal coming across them. Because here's the things that are true. If two lines that are parallel are cut by a transversal, meaning that a transversal comes across and shoots across both of those lines there, then here are the things that are always true if they are parallel. This is only true when they're parallel. Number one, the corresponding angles are congruent. So if I look at the corresponding angles, remember that's like the upper left-hand angle and upper left-hand angle, upper right-hand. So like this one up here, the upper left will always be congruent with this one down here, which is the upper left as well. This one here will be congruent with this one here. This one down here, 2, 3, will be congruent with this one. 1, 2, 3. Finally, 1, 2, 3, 4 will be congruent with 1, 2, 3, 4. 4 lines there, 4 lines there. So it's just identifying the congruent angles. So all the corresponding angles will be congruent, the ones that match up to each other. However, there is something else that is true. The alternate interior angles will also be congruent. So I'm going to draw that again. Let me just make my arrows a little bit faster here. Transversal cutting across. Remember, alternate interior angles, I'm going to zoom in for a minute so you might lose your definitions for a second. Alternate interior angles are the ones that are on the inside, which is this area here. And they're on opposite sides. So like this angle. Oops, somebody's Life 360 just went off. So there's this angle right here and this angle right here. Those are alternate interior angles. They are congruent, but same with the ones on the other side. This guy right here and this one right here are also congruent. So alternate interior angles are congruent. Corresponding angles are congruent. The alternate exterior angles are congruent. So let me mark the alternate exterior angles. Here's an alternate exterior angle. Here's an alternate exterior angle. I'm going to change it to 3 because I want to indicate the same amount of lines to show that they match up there. And then this one up here. 1, 2, 3, 4. 1, 2, 3, 4. Alternate exterior angles are congruent. Now this is the one that everybody messes up right here. This fourth one. Star it because this is like a common mistake. It's the one that everybody keeps going, they're all congruent. They're all congruent. They're not all congruent. They're all congruent but one. And the same side interior angles are supplementary. What does supplementary mean? They add up to 180 degrees. So watch what I'm going to do here. I'm going to do another 2 parallel lines. I'm going to have a transversal that comes across it. So look at the same side interior angles. Same side interior angles are on the same side in the interior, so these two. If you look at that one up top that I just marked, that's an acute angle. Like it's less than 90 degrees, but the one below is an obtuse angle. So they definitely could not be congruent. But what they could do is when you added them together, they will equal 180 degrees. Only when the lines are parallel. When they are parallel, that will always be true. Same with the other two on the other side. Yes, ma'am?
So they're not adjacent?
No, those two are not adjacent. Remember, adjacent ones are ones that, like these two up here, like notice we have opposite rays, and then we have this common side there. These two right here would be adjacent angles. Yes, ma'am?
Would we be given examples where the lines aren't parallel?
So sometimes, but right now our focus is right on parallel lines and understanding the relationship. So we will make a connection between these. So sometimes you'll be asked to solve for x and you'll have something for this one and something for this one. It's key to understand that those two things, whatever they are, need to add up to equal to 180. So you just set it up that way. All right, I'm going to pause it for a minute because I know some people still have some writing to do. I'm going to pause it for literally like 60 seconds to get caught up, and then we'll move on. Degrees. So anytime you have same side interior angles, they will equal 180 degrees. So I mean, I can prove it to you. Like we can actually prove it. Like, so would you agree that, let me just prove it to you. So her question is this. She's like, why are they supplementary? Okay, great question. It's a valid question. Let me prove to you why they are. So let's take for a minute. I'm just going to look at, I'm looking at that this area right there. Would you agree with me that this angle right here and this angle right here are supplementary, that they add up to 180 degrees? Are we okay with that? Mm-hmm. Okay. Now, I want to do something here. I want you to pay attention to this angle right here, okay? That one right there. Would you agree that in the very first line, we learned that corresponding angles are congruent? So that must mean that this one right here is exactly the same. Like that these two right here are exactly the same. Would you agree with that? So if these two add up to 180, wouldn't it also be true that these two add up to 180? Because look, I've got a single line plus a double line that adds up to 180. And then I've got another single line and another double line. They have to add up to 180 as well. Does that make sense? Okay. Okay, so we're going to try to find the angle measures here. A couple things that we know is that I can tell right now that these two lines, the ones going this direction, are parallel. Now there's two different transversals. There's a transversal on the left going up and down, and it is perpendicular to both lines. It makes 90-degree angles. The ones on the right are not perpendicular. They make all different sorts of angles. But we're going to try to use all those things to figure it out. Sorry, I'm just taking a look here for a second. So we could go in order. We could look at these angles and go in order and say, we could go in order and do angle 1 and angle 2, but actually I think it's easiest if we kind of approach this for anything that we see. So we're going to look at the angles and say, which angles do I know up there just from looking at it? What's one that you know?
You can see that the top right on the bottom one is 130.
Okay, so this angle right here is 130 degrees.
And then the corresponding angle is angle 2.
Angle 2 is corresponding. Therefore, angle 2 is what? 130 degrees. So let's do this. Let's agree that instead of trying to answer all those questions there, let's just fill in everything that we know. Like if you see something, you're like, okay, well, I know this is true. Now, it's not, you know a lot of things. You know about angles that are supplementary. You know about linear pairs. You know about vertical angles. You could start filling in a lot of this information. Colette, give me another piece of information. Angle 5 is how much? How did you know that this was 50 degrees? Good. These two together right here have to equal 180 degrees. They're supplementary. Somebody else, give me a different one. Yes, ma'am.
Angle 4 is 50 degrees.
Angle 4 must be also 50 degrees. Why?
Because 130 plus 50 equals 180.
Those two together are a linear pair. They'll make 180 degrees. Audrey, take it.
Angle 1 is 50 degrees because it has to equal 180.
Good. These have to equal 180. But what if I needed another reason why it was 50? What if you needed a different reason?
1 and 4 vertical angles. angles.
1 and 4 are vertical angles. You could use that way too. There's not a right way to do this here. It's just which way did you use. All right, so look how much we've already figured out. Give me another angle up there. Yes, sir.
Angle 3 is 130 degrees.
How'd you know that?
Because 2 and 3 are vertical angles.
2 and 3 are vertical angles. Somebody else, somebody different. Yes, sir. Number 8 is 90 degrees. How'd you know that?
Because the transversal, the perpendicular is 90 degrees.
Yeah, it's perpendicular there. It makes a box. That box means 90 degrees. Give me another one. We have 3 more angles up there we can label. Yes, ma'am.
Angle 6 is 130.
And what did you use to find that?
Because angle 6 and that angle are vertical.
Good, vertical angles. 2 more angles that I need labeled here. Yes, ma'am.
7 is 50 because the vertical angle is
Vertical angles again. You could have used a linear pair. You could have used vertical angles. There's only one more that's not labeled up there, and it's actually one of the easiest ones up there. Yes, ma'am.
the one in the top left corner.
Top left. How much is that one?
90.
Okay, so now let's go through and just answer these questions. Angle 1, oh, I see it's 50 degrees. Angle 3, 130 degrees. Angle 5 is 50 degrees. Angle 7 is 50 degrees. Angle 2 is 130 degrees. Angle 4 is 50 degrees. Angle 6 is 130 degrees. Angle 8 is, where's 8? Oh, 90 degrees. So it was much easier to find all these things once we knew some information. Like we started piecing around and putting the puzzle together. So again, sometimes people want to start on the left and they get really confused. But I always say, let's just figure out everything that we know and then answer the questions afterwards. All right. Now they say find the missing values. So we need to find x, y, and z. Now here's the things that are true. If you can't see it very well here, there are arrows here. Here's one arrow. And here's another arrow. What does that indicate about those 2 lines? They're parallel. Now notice this one has a double arrow, and it has a double arrow. That is because it's not parallel to the first set of lines. These lines are parallel themselves. So these red ones are parallel, and the yellow ones are parallel. Now, you just learned a lot of things about parallel lines and the connections that we can make between them. So let's talk about this. Let's talk about like maybe a connection that we can make. Yes, ma'am.
So I guess I'm going to start with the 110. And we know that 2z and 110 are equal because they're corresponding angles.
Beautiful. Those are parallel lines, and those 2 are corresponding angles. So if you're like, wait, why are they corresponding? Because look at just this right here. If I look at just that, the 2 red lines are parallel. The yellow line is a transversal. They're both in the upper left-hand corner. Therefore, what is true about those 2 things? 2z is equal to 100. Now what?
110.
Oh, was it 110? I'm sorry, 110.
And now you're going to divide 110 divided by 2 to
Okay.
form z.
All right. So what is z equal to? 55 degrees. Fantastic. So this is 55 degrees. Perfect. Well, we've got z is taken care of. Z is, actually, I shouldn't say that. That angle is not 55. I'm sorry. I labeled that as 55 degrees. Let me go back a second. Z is 55, and that's why 2 times 55 is 110 degrees. That's why, I'm sorry. I shouldn't have labeled that as 55. It's Z that's 55, and 2 times 55 will give me the 110 that I need. Yes, sir?
What postulate did you use to find that?
So that is the corresponding angles postulate. That first one that said, if 2 lines are parallel, then their corresponding angles will be congruent. That was that very first one in that list. Yes, ma'am?
Because 2y and 2z are same side interior angles.
Okay, good. So
They're supplementary.
2y and 2z are same side interior angles, therefore they're supplementary. So what should I do with them?
So you have to put, so because z is equal to, 2z is equal to 110 would be 2y
Good. So let's do that substitution property and just swap that out.
plus 110 is equal to 180.
Beautiful.
And then you subtract 110 from both sides,
Okay, and we get?
and then you get 70. And then you divide it by 2 on both sides.
Okay.
and you get 8.
Perfect. So y is equal to 35. So that means that this angle right here, 2 times y would be how much? How much is 2y? That's 70 degrees right there. Because y is 35, and that angle says this angle is 2 times y. So I'm just plugging in the y there. Last but not least, how are we going to find x? Yes, ma'am?
X is equal to y, so it would be 70 degrees.
Good. So x is equal to 2y, and we already know that 2y is 70 degrees. All I did is a little substitution there. So x is 70 degrees. And that should make sense because you know these two are corresponding angles, therefore they must be the same amount. Yes, ma'am?
Our, oh, I blanked.
Okay.
Our x and 110, oh, x and 110 are supplementary.
Yep, these two, and it makes sense because look, 70 and 110 are 180. These two are same side interior angles. They equal 180 as well. If they don't, that means something's off. Yes,
I
sir.
don't know if this would actually happen, but if there was like a third pair of parallel lines, would they have 3 arrows?
So yeah, if we add another set somewhere, like we could have, like let's do something weird. Now, trust me, you're not going to see something like this at this point. But like in higher level math, sure. Like let's say we had another set that went like this. It's possible that they could have 3 arrows as well. I'm going to take that off. I'm going to undo it there so it doesn't go on the diagram. But yes, you could have 4 lines, 5 lines. You can have as many as possible. It just starts to get very busy. All right, our last possible slide here. Excuse me. When sunlight... All right, let's try that again. When sunlight enters a drop of rain, different colors of light leave the drop. When sunlight enters a drop of rain, different colors of light leave the drop of rain at different angles. This process is what makes a rainbow. So this is all true. This is all like the reason we see a rainbow is because when the rain is falling, light hits it, and when light hits this water, the different colors of light reflect at different angles. And like if you haven't learned about that in your science classes yet, you will. The process is what makes a rainbow. For violet light, the measure of angle 2 is equal to 40 degrees. So it means that the angle, so like the light is coming down, it hits this water droplet, and then it's going to come back at an angle of 40 degrees. What is the measure of angle 1? And how do you know? So one thing that they're showing us is that the light is hitting this person, I can't tell if that's a guy or a girl, right in the back of the head. It is parallel. All light coming down to Earth will always be parallel. It's just coming down like that. So we know those are parallel lines. We have this transversal, which is the violet light coming from, I don't have violet as a color on this, so I'm just going to use blue. It's coming across. We know it's 40. So what else do we know? Yes, ma'am.
Well, I think the measure of angle 1 is 40 because they're alternate interior angles.
Good. So the alternate interior angles postulate says that these two alternate interior angles will be congruent only because of this, though. Because the lines are parallel. So I say that, and I'm going to say it so many times that it's annoying, because sometimes people try to use it on lines that aren't parallel. If they're not parallel, you can't assume that. It's only because they're parallel that will always be true. So when we've got parallel lines, that ties back to our second slide, first or second slide, where we had our postulates that says that alternate interior angles, when the lines are parallel, will always be congruent. Yes, ma'am?
So on the quiz or test, are you going to have us justify like the reasons why we put, for example, here measure of angle 1, or are you just going to have us find?
Boy, are you going to hate the answer to that question. So the better question is, why am I having you learn all these postulates? Because you are going to have to use them in a proof. So at some point, you're going to say the measure of angle 2 is equal to the measure of angle 1, and I'll go, oh, really? Why? And then you're going to go back to that very first slide and say alternate interior angles. But that's all you have to say, alternate interior angles. That's it. So it's not that bad. It's what you're doing already. Like, I'm giving you some information. So this could be a proof. Given that the measure, like, look, let's play proof time. Let's pretend this is like, so because some people stress out. Given that the measure of angle 2 is 40 degrees. They gave that to us, right?
Yeah.
Prove that the measure of angle 1 is 40 degrees.
Okay.
Well, we would say that the measure of angle 2 is equal to 40 degrees, and then the measure of angle 1 is 40 degrees. Why? Because of alternate interior angles. That's it.
Will the stuff from chapter 2 be on?
Yes. And that's the part that people don't love. This is a constant list that builds. Vertical angles theorem, you'll still be saying that in the fourth quarter when you're doing proofs. You'll still be saying linear pair postulate. You'll still be saying alternate interior angles. Now, I will tell you this. These ones that we're doing now, you tend to say more often than everything else. Well, I mean, you always end up doing things like the addition property of equality. You add to both sides, you subtract both sides. But after that, like these are the number ones that you do all the time. Vertical angle. There's some that don't come up as often, but the ones that we are learning in here they come up all the time. Yes, ma'am.
Are we gonna be doing proofs for the rest of the year? Are they gonna be involved in?
Yeah.
considerable
Yeah. Yeah. Proofs are just going to be here all the time. So they're there. I'm sorry, but I'm going to tell you right now. I'm sorry, not sorry. You know what I mean? And I'm saying I'm sorry, not sorry because of this. I honestly think that you all are in here because whether you value this in yourself or not, you're all extremely good at math. Now you might be like, no, she, he, they're better than me, whatever. I go, whatever. There's geometry teachers out there who are better than me. I go, we can't sit there and value ourselves based on other people because you'll never win that way. But you do have to just think about, well, you're right. I'm pretty good at this. Like, I'm not bad. Sometimes I get stuck, but I can do this. And you go, and then that's what makes this different than the regular classes, that they're not doing these proofs. And you are, and you can make this happen. So, like, that is what makes this class tougher. So, love it or hate it, that's the difference.